Okay. So today we're going to look at matched samples. On Monday, we looked at the inferences about the difference between the two population means and we were looking at independent samples. So today we're only going to look at not only, we're going to look at the matched sample. And then second half of the session, which will start at 4, we will look at the proportion. The only thing I am not going to cover is the other part of the independent or the other part of unmatched samples where we use the F test. We can have the discussion for that at the later stage. It's part of the ANOVA. For now, I'm only going to concentrate on this last two so that then you have a feel of the two tables that you use and how you interpret or do the hypothesis testing and the confidence intervals calculations. And then the others, they just follow the same format. Okay. So, do you have any questions regarding the last session that we had? If not, then we will continue because the base of today it's from building up from what you've learned last week. And if you, not last week, on Monday, if you struggled on Monday, then I feel today, if I'm moving too fast as well, because the sessions are too condensed, let me know so I can slow down. And remember, there will be exercises. You need to do those exercises. If we don't cover all the exercises in this session, you can still do the exercises at your own time and share your workings with me on WhatsApp, and I can guide you where you're going wrong or if you're doing it correctly, then I will also tell you that you are on the right track and then you can move on. Okay, so let's look at hypothesis testing of the means when we have two related populations and those two populations are matched. When we have those, therefore it means they are paired, then you will have the observation that come from both of those populations. We will go and do the difference between the two, and we will have your X difference, which we will use to do any calculation to do the test statistic or to do the chi-square statistics. And like with any other inferential statistics that you do, you always have to make sure that your assumptions are met. And for this, the assumption is that both the population needs to be normally distributed. And if they are not normally distributed, therefore the sample size that you are going to select from there needs to be large. And large by meaning n should be greater than 30. Okay, and these are the calculations formulas that you will need to know and you'll need to do before you can start doing any hypothesis testing. So the first step, when we have the X observation, we're going to take the difference. After getting those differences, then we're going to calculate the mean, which is your XD. And I think in your module, you use X bar. So we will mean the one and the same thing. So we'll take the means, and therefore the means will be the X bars. It will be the X bar difference. And then we can also calculate the standard deviation of those differences, and those standard deviation will also be the SD for your standard deviation. I need to also show you on how to quickly do this on your calculator without you having to calculate things manually, because it's also time consuming to calculate the SD. But if I will show you on my calculator, and hopefully you are able to go and practice the calculation on your calculator and come back and we can look at how I can help you simplify things much better. Okay, so at the later stage, when we do the hypothesis testing, we also need to calculate the test statistic. And to calculate the test statistic, we will need or require those values that we calculated prior. For example, the test statistics will be your sample mean, which is your D, minus the population mean, which will always be equals to 0. So therefore, it's the same as D divided by your standard deviation divided by the square root of n. And we know that the standard deviation divided by the square root of n is your standard error. So in the exam, if they ask you calculate the standard error, because they're not going to give you a formula and call that formula standard error, they might ask you calculate the standard error. And when they ask the standard error for the population to population mean where they are matched, the standard error is SD divided by the square root of n. And we know that our T statistics has the degrees of freedom of n minus 1. And we will use that when we find the critical value as well. Like with any hypothesis testing, remember, I just want to refresh your mind. You need to remember all the 6 steps, because all the 6 steps are part of the question that you will receive when you answer any question in the exam. You need to know that step number 1, you need to state your null hypothesis and alternative hypothesis. Step number 2, you state what you are given. For example, what is the value of your alpha and what is the value of your n? Because if you know those things, they will help you at the later stage as well. And then you need to determine what kind of a test statistics you are going to do, because that information will help you know whether are you going to do the Z test or are you going to do the T test. And with that, it will tell you whether are you going to find the degrees of freedom and where are your region of rejection will be in terms of you finding the critical values. So finding the critical values, you need to know which table to use. If you're doing a T test, you need to use the T table. If you're doing the F test, you will need to do the F. We will need to use the F test table. If you're doing the Z test, you need to use the Z table, which is your cumulative normal standardized distribution table. But we will get to that at a later stage as well. You also need to know how to find the critical values. Like I explained, you will need to find the critical values on different tables, depending on your test statistic that you're going to be doing. And because the critical value helps you with defining where your region of rejection are, then it is also very important that you do it correctly. And once you have your critical values defined, then you can calculate also your test statistics now. And when you calculate the test statistic, it will help you when you get the answer to see where that test statistics falls on the critical value region of rejection. Whether do you reject or whether you do not reject. And that comes to help you when you do your decision and making your conclusion. Because if you reject, then it means your null hypothesis was not true, then your alternative stands, and so forth. So you need to know these 6 steps for hypothesis testing, regardless of which part of the section you are at. You will need to know the 6 steps. So let's look at how we do the hypothesis testing for the PET sample. Like with any other, so your two-tailed test will always state the mean difference, because you're looking at the differences between the mean. The mean difference will be equal, or your null hypothesis will say the mean difference is equal to 0, whereas your alternative will be the opposite of that, which will say the mean difference is not equal to. And that will mean you are going to find 2 critical values or 1 critical value with 2 rejection areas. And you will use those to make your decision. And this is what we call a two-tailed test. And for a one-tailed test as well, it will say the mean difference is greater than 0, or it's less than 0 for your alternative. And it means you only have 1 rejection area, and you're going to use that to make your decision. And for the other one-tailed test, when the researcher wants to prove that the difference is less than 0, therefore the alternative will say it is greater than 0. And we will use that to define your critical values, because then to define your rejection area using your critical values, and that will tell you where is your rejection area, and you can make conclusion based on that. So it is very important to know what kind of a test you are doing, because that also has an effect on how you're going to make a decision at the end. Okay, so let's look at an example. Let's say we assume you sent your salespeople to a customer service training workshop, and you want to find out, has the training made a difference in the number of complaints that you receive? And you go and you collect the information from those salespeople. So we know that before training, CB received 6 complaints. After training, you still received at least about 4. And TF used to get 20 complaints. After training, he gets 6. Because I have from the same population, I have the before and I also have the after. Then with that, I can find the difference between the two, so that I should be able to test my hypothesis that has the training made any difference. And based on the formula that I know that I'm going to be using, which is the test statistic, it requires me to find the mean of the difference between the mean the mean of your sample, because my first sample will be for the before and my second sample will be the after I took them to training. So I need to find the difference between the two, and I need to divide the difference by the standard error. And if I need to do that, therefore, it's easy. You just create another column next to that one, and you just calculate the difference. And your difference for the first one is 6 minus 4, which is 2, 20 minus 14, which is 1, and 0 minus 0 will give you 0, and 4 minus 0 is minus 4. And that is your difference. And remember those other measures that I spoke about. I said, once you have the difference, we need to calculate the mean, because in that formula, we are actually calculating the mean. And I said, the mean is the sum of your observations, which are your differences. Your sum of your different observations divided by how many they are, which I add all of them, and I can see that if I add all of them, there are 21. And I divide that by n, which gives me minus 4.2. That is the mean difference. I also want to show you, I hope it's going to be very clear on the calculator. Let me see if I can share my screen from my calculator. And then I can show you how to calculate the mean before we continue with this session. If I can. Let's see. It seems like I am not able to share my screen, but then it's fine, because I was going to show you. Probably I will do that at a later stage, so it's fine. Anyway, but you calculate the mean, and the mean you just add all of them up and divide by how many they are, which is minus 4.2. And then you calculate the standard deviation. To calculate the standard deviation, and that's why I was hoping I can show you on the calculator, which makes it easier, is the sum of your difference minus the mean squared. So it means you say minus 2 minus 4.2, and then you square the answer, and then you do the rest like that. So you will say minus 2 minus 4.2, and the answer for this, you square it, and you do for all of them. Minus, it will be minus 4.2, and you square the rest, minus 4.2 square, 0 minus 4.2, and then you square, and you do the same, minus 4 minus 4.2, and you square. And when you have the answer for all of them, you can add them, and when you add them, you get the total there. And once you have the total there, you divide by n minus 1. Yes?
I can't see your working out on the screen.
Is it not visible?
No.
Okay, let me clear out. Okay. I am going to stop sharing and then share again, and let's hope you should be able to see. Are you now able to see the screen?
Yes, thank you.
Okay. Oh, sorry, I need to go back to where we were. Okay, so I was saying to calculate the standard deviation, you have to subtract. So the formula says your difference minus the mean of the difference. So you're going to say minus 2 minus the difference that you got from the mean, minus the mean, and you square the answer. And you go and do the same. You square the answer, and then when you're done, you're going to add all of these answers together, because that's what the summation is for. And then you add all of them, and you will find the answer, which will be whatever the number is. Divide that by n minus 1, which will be your n minus 1 will be, there are 1, 2, 3, 4, 5. There are 5, so it will be 5 minus 1, which is 4. So you will get the answer there and divide it by 4 and take the square root of it, and it will give you 5.67. And that's how you calculate the standard deviation. And once you have calculated all this, then it's easy, because we're going to use this at the later stage when we calculate the t-test. So let's do the hypothesis testing. And to do the hypothesis testing, remember, if also in the question they tell you that you must calculate the hypothesis testing at an alpha 0,01. Sometimes, like we did previously, they might give you at the confidence interval or confidence level, and you need to calculate your alpha. But if they give you alpha, like they did right now, where they say alpha is 0,01, it's easy. You don't have to calculate alpha because they're giving it to you. So you state your null hypothesis and your alternative. That is step number 1. Your null hypothesis will say the mean difference is not equal, or the mean difference is equals to 0, and the alternative will say the mean difference is equals to 0. So therefore it means there was no change in terms of the number of complaints before and after. Okay. And step number 2, we state what we are given. So we know that we are given alpha of 0,01, and we calculated the mean difference, which was minus 4.2. Now, when we have alpha, we can go and calculate the critical value. Not even calculate, but go find the critical value, because we know that when we have alpha, our critical value, which is T alpha divided by 2, with the degrees of freedom, and our degrees of freedom, T alpha divided by 2, and the degrees of freedom, which is n minus 1. I'm sorry for my pen. N minus 1, which we know that T alpha is 0,01 divided by 2, and our degrees of freedom is n minus 1, which is 5. There were 5, so it's 5 minus 1, and our T will be 0,005, and the degrees of freedom of 4. So if we go and the degrees of freedom of 4, I'm going to go out and keep. So remember that it's T 0,002, 0,005. That is our 0,005 and our degrees of freedom of 4. So you go to the table. I've opened your past exam paper. You go to the table, you go to the T table. So you scroll to the T table. It should say, it's somewhere at the back, at the end there. It's critical values of T. We used this on Monday as well. So you come here, you go look for T 0,05 at the top, which is the last row, and you look for the degrees of freedom of 4, which is there, and where they both meet, which is 4,604. And when we have that, and that's how you find the critical value. And you go find the critical value, and the critical value is 4,604. And once you have the critical value, therefore it means you are able to place the rejection areas on the graph. It's easier when it's visual. So I put my rejection areas. I know that it's a two-tailed test, so therefore it means I have 2 rejection areas on the negative side and the positive side. And step number 5 is to calculate your test statistic. So you calculate the test statistic. We know that the test statistics was the mean minus the population mean, which is always equals to 0, which will be equals to 0, divide by the standard error, which is your standard deviation, divided by the square root of n. Remember, we calculated the standard deviation earlier, and we found that it was 5.67. So we just substitute all the values that we've calculated. We know the mean difference was minus 4.2, and that's what we put. Our population mean difference is always going to be equals to 0, so we put the 0. And our standard deviation was 5.67, divided by the square root of n, which is 5, and the answer we get is minus 1.66. And when we have that, we can go and place it on the graph on that rejection area and see where it falls. Remember, the white area, it means it's the do not reject area. So in this is the do not reject. So we do not reject area. So it falls within the do not reject, the DNR. So it means if our test statistics falls there, we can make a decision and do not reject the null hypothesis in that case, because our T statistic, which we calculated, falls inside the do not reject area. And in conclusion, we can say there is not sufficient change in the number of complaints that we have received, because if we reject in the null hypothesis said there was a difference in the number of calls received prior to receiving training, after receiving training. And that's how you do the test statistic. Any questions? If there are no questions, we had an exercise, which I don't think you will have time to do that exercise. But just to show you, when you do this exercise at home alone, when I'm not there, so that then you're not getting lost, these are the type of questions that you will get. A random sample of 6 workers is used, and the data of those are that, and they give you the table. In your exam, it's easy because they already calculated your differences for you. So you don't have, I looked at a couple of papers. You don't have to calculate the difference. They've already calculated them for you. So the only thing that they do not calculate here is
Hello, ma'am.
Hello?
Yeah, so I'm seeing on this example that you are saying, the exercise that we must do, they are saying method 1 minus method 2. But on the example that you did, you say 2 minus 1. I think there is a difference.
There is no difference. Sorry, since I used the actions on this thing. I didn't say 2. It's the same. It's from you can do 2 minus 1 or 1 minus 1 is still going to give you the same. Because we just
but is it not like the test statistic? If you say 2 minus 1, it will come as a negative minus 1 point. But if you do 1 minus 2, it will come out as a positive. Does it have any effect?
When you do, sorry, wait. You mean
from our data?
Yes. Or you mean when you come and do the test statistic, when you come and do the calculations?
Yes,
for
after
example,
you do.
There when we did the calculations.
It was supposed to be positive 1.66. Because on our assignment, if you see, they will give us 2 answers. One will be negative and the other one will be carrying.
Will be. Okay. So on this, no, you need to say 2 minus 1. So it's method 2 because you want to see the difference between the two. It will be the difference of method 1 to the difference of method 2. And so on this one, they used method 1 minus method 2. I guess that's what they did. And on my exercise, I said method 2 minus method 1 because I wanted to know after training, did anything change? Which training happened after method 2. So that's why I did method 2 minus method 1. And on this, probably they will also tell you in your exercises which differences you must do. For example, like this, set population 1 minus population 2. And that is why probably they will give you the difference because they want to force you to use the differences as they created them.
Okay, I get it now.
Yes. So you will use those different, let's go back, boom, come back to here. So they will give you the difference. So you don't have to worry about calculating the difference and knowing which one to subtract from which one. So they tell you in this because they already did the difference for you. All you need to do from here is to calculate your mean. And remember your mean in your module, I think also you use XD. So your mean for SD will be your difference, which is your D minus, or your D divided by N. You need to calculate that because you will need to use that in your formula. And then you also need to go calculate your standard deviation, which is the square root of your sum of your difference, which is your differences, minus your differences minus the mean, which is XD difference, and squared divided by N minus 1, because you have to do that. And once you have those, then you are able to calculate any other test statistics that they give you. But to bring you to attention is, as you look at the questions that they gave you, you will notice that all the steps, or all the 6 steps of the hypothesis are here. Number 1, they ask you, what is the null hypothesis? How will you have identified what null hypothesis should have been from this? Because they would have told you from the questions, they said the population mean method 1 is less than the population mean of 2. Then they already are telling you that they are looking for the less than or equal. And therefore, it means your alternative hypothesis will be the inverse of that. Remember also, what I forgot to mention as well is, in your null hypothesis, there is always going to be an equal sign. Whether we put the less than or equal or we put the greater than or equal, it doesn't really matter, because there is always going to have an equal sign. The only thing that does not require an equal sign is your alternative hypothesis. So in your alternative hypothesis, let's say, for example, because this is what the researcher wants to prove, and the researcher here said it is less than. Because of the less than, you cannot put it in your null hypothesis. It can only go in your alternative hypothesis. But then, because it says it's less than, therefore it means your null hypothesis should be, your alternative hypothesis should say a less than. And this is where, if you did 1501, you will remember that this is where if you reject your null hypothesis, it means you are rejecting, you are committing a type 2 error, something like that. So you need to know how to state those null hypothesis and the alternative, because a less than cannot go into the null hypothesis, it can go into your alternative hypothesis. So based on that, you are able to see whether that statement for your null hypothesis and alternative is correct or incorrect. And then remember, with the step number 3 or step number 2, where you state what you are given n, and you can say your n is how many? There are 6, so your n is 6. But then question number 2 or option number 2 is asking you what is the degrees of freedom. And we know that the degrees of freedom is part of step number 3, where we find the critical value, or step number 4, where we find the critical value. And therefore it means you can say your degrees of freedom is n minus 1, and is that the n minus 1? Also, you can make that conclusion based on that. Then step number 4 as well talks to your critical value, and you can see that option number 3 is asking you if you have 5% level of significance, is that your critical value? So it means on here you will need to go and find alpha divided by 2 and your degrees of freedom. And if your degrees of freedom, you found it right there in step number 1, therefore it means it's going to be easy for you to use the information from option number 2 to go and find the critical value on the table. Remember, you're going to say 0.05 divided by 2, and you will say n minus 1 is 6, and then you go to the table, the T table, to go find your critical value. And then they're also asking you to define your, or to make your conclusion. But you cannot make your conclusion if you do not know how much is your, if your test statistic is. And here they say your test statistic is greater than your critical value, and they give you, so your rejection area is your critical values. So they say your rejection areas for this question should be greater than. Is that the correct one or the wrong one? I don't know, because you need to know the rejection area based on your hypothesis testing. So number 1, if your number 1 is incorrect the way it is right now, therefore it means number 2 is incorrect the way it is. So you will need to go and find those. But here is the catch. With number 3 and number 4, they mean one and the same thing actually. Because number 3 and number 4, they are both asking you for the critical value, because once you have gone and found the critical value on the table, you are able to define your rejection area. And that is also based on number 1. If your number 1 says it's greater than, therefore your rejection area will be on the right. If it's less than, your rejection area should be on the left. So then it should say the test statistic is less than the critical value. And that value that they have there is the value of your critical value. So therefore it means that is the rejection area value. So which one of the two is the right one? Remember, you are looking for the correct answer. And then the other thing is your test statistics. In this instance, they are asking you to also calculate what your test statistics will be. So your test stat, you remember, it is your mean difference, which you would have calculated there, minus 0, divided by the standard deviation difference, divided by the square root of n, which is your standard error. And once you have calculated that part, you should be able to state whether option number 5 is correct or wrong. And that's all how you answer all these questions in the exam, because all the 5 steps of the hypothesis testing are embedded in the options. So you need to know those steps. The other time, they might just ask you to calculate the critical value. You know how to find the critical value. And also this one also talks to the critical value. But that is what you need to go and do on your own, and then we can discuss that on WhatsApp. Any other question? And then we can do the confidence intervals. Do you have any question? If there are no questions, then let's look at how we find the confidence interval. Finding the confidence interval, we use the formula. So it's still the mean difference plus or minus your critical value, which is T alpha divided by 2, and the degrees of freedom. Don't forget that with the degrees of freedom, because you need to go find the critical value on the table, times the standard error, which is your standard deviation difference divided by the square root of n. So let's look at an example. We're going to use the same example that we had there. So we know that our mean difference is minus. I need to write this because I'm going to do a black screen. The mean difference is minus 4.2, and we know that our standard deviation is, our SD is 5.67. And we know that we went and we found our critical value. Remember, we went to find the critical value, and we found the critical value to be 4,604. I'm not going to go again and do all the critical values and all that, because we already did that. We know that it was T0,01 and 0,5 and 4, and we found that it was 4,604. And then I'm going to go black screen so I can write on the screen. We know the formula. It's asked for the mean difference plus or minus our critical value, alpha divided by 2, and the degrees of freedom, which is n minus 1, divided by the standard deviation over the square root of n. We know what our mean is, and we know that our mean is minus 4.2 plus or minus our critical value. We found that was 4,604 times our standard deviation was 5,67 divided by the square root of n, and our n was 5. And our n is 5. So we can calculate our confidence interval. So to start with, we start with what is inside the bracket, which says 5.67 divided by the square root of 5, which gives us 2.535701. And I need to multiply that with the critical value of 4,604, and that gives me plus or minus 11,674,368. Remember to keep all the values, only round off when you get to the final answer. And that will be minus 4.2. And now let's use black. So now we can do our lower boundary, which is minus 4.2 minus 11.674,368. And we can do the upper boundary, which is minus 4.2 plus 11.674,368. 368. And we calculate that minus 4.2 minus 11.674368 equals minus 15.8. Let's keep it to 2 decimals. 87. And that is my lower boundary. My upper boundary is minus 4.2 plus 11.674368 equals, and I get 7.4743. Okay, we said we're keeping it to 2 decimals, so let me keep it to 2 decimals. So it's 7.47, and therefore it means my mean of the mean difference is between those two values. It lies between minus 15.87 and 7.47, and that's how you do your confidence interval for the paired population or paired samples from two populations. Any question? If there are no questions, there is your exercise. You have the mean difference, and from there you can calculate or find the confidence interval. So it's similar. You need to go calculate what your SD is, your mean difference, which is the sum of your differences divided by n, and you're going to find your SD, which is the square root of the sum of your difference the square root of the summation of your differences come on, your mean difference minus your differences minus the mean differences minus the mean difference squared divided by n minus 1. You go find that. And once you found that, then you can come and substitute into the formula. Plus, and you go find the critical value because it's T alpha divided by 2 and the degrees of freedom times the standard error, which is that. And we know that our degrees of freedom is n minus 1. And remember that alpha, which is 0.95, is our confidence level, and we can find it by saying 1 minus alpha to go find the value of alpha. And when you have the value of alpha, you substitute into the formula and you find the critical value on the T table.
Hi, ma'am.
Hi.
Are those differences, is it 0.6 or?
Those are 0.6, yes. It's 6 minus 5.4 is 0.6.
Okay, thank you.
Okay. I think there might be a light at the end of the tunnel. Let me just check something here so I can do this for you. Okay.
Sorry, ma'am, I
Yes.
can't see the question.
Yes, I know that. Just give me a
Okay.
sec.
So,
Okay. You won't be able to see the presentation because I want to show you the following. I have the answers in front of me. For example, those 0,6, 0, minus 0,2, 0,5, and 0,3, and 0 and 0,6. I want to show you, I don't know what kind of calculators you are using. If you are using a sharp calculator, where you see my ENT, where you see that ENT on my scientific calculator, that is the M plus on a normal sharp calculator. It's like your M plus, M as in Martha, M plus. I'm just going to show you how quickly and easy it is to calculate the mean and the standard deviation. The first thing that you need to do on your calculator, mine is already on state mode, so I can take it back. So it should be a normal mode calculator. So for example, your calculator are always like this. And then to take it to the state mode, because we want to capture all the values, you press the mode function. There is a delay a little bit, and then you press 1 for state. All calculators have the state mode. And then I'm going to press the SD for the standard deviation. It's for the descriptive standard deviation, the descriptive stats, which is 0. And then I'm going to capture the information. It is easy to capture the information. I will also share with you the document on how to do this on any calculator, including the Casio or this calculator that we have. So I'm first going to capture the information we have in front of us, which is 0.6. So 0.6, there is a delay on my side, so it's 0.6. And then you're going to press the plus or minus. So on my one, it's M plus, so I'll press the plus or minus and it will say data set 1. You will see when I capture all of them, it will keep on telling me what data set number I'm on. So to capture the next one, I just continue like that and it's minus 0.2 and then I go and press the plus that and I will just continue 0.5 and M plus, which is my enter, and 0.3 and I press my M plus and it should say data set. Oh, it says data set 13. I should be on data set 1. So I can see that I've made a mistake. I can go out by pressing the mode and then second function mode. Sorry. To clear your calculator, you press second function, and then you press the mode button. It will clear your calculator. So I'll do that again. It's 0.6 M plus, and then minus 0.2, minus 0.2 M plus, and then 0.5 M plus, 0.3 M plus, 0 M plus. I need to also capture that 0, and you need to capture them in an order that they appear. 0 M plus and 0.6 M plus. And once I have all the data in my calculator, I've stored them. You will notice on your calculators, some of them have the mean on button number 4. If you are not able to see that, that is an X bar. And I can zoom in onto that. You will see, it's not that clear, but that is an X bar. And then next to it, there is an SX, if you look at it on button number 5. Those are the two functions that I will use. One is to calculate the mean, and the other one is to calculate the standard deviation. So to do that, I'm going to go up. It means I need to press the green button. So if you press the alpha, and then you press button number 4, it will give you the mean. So you will see that that is the mean, our mean difference. And then you press the equal sign, it will give you the mean difference of Let's go there, of 0,3. 0,3. To get the standard deviation, also same. I don't have to clear my calculator or anything. You just press the alpha button and then press button number 5. And you will see it will say SX. Something went out. Let's see what went out now. Okay, let's see. Sorry. I hope it's gonna go back. Okay, so SX, and then we press equal sign. And that will give us our standard deviation SD as 0,33464, or you can round it off. And that's what you're going to use to substitute into your formula. I just wanted to show you that how easy it is and quick it is to calculate all this by just putting in on your calculator. I'm going to stop sharing on this and go back to the question because we already calculated them. So I'll go back to the slide, sorry, and come back to the slide. And we should be back. Are you able to see the presentation now?
Yes, thank you.
Okay, so now we've calculated the mean because I wanted to save you a lot of time. So we calculated the mean. Let me use the red pen. We calculated the mean and we found that the mean is 0,3. That's what we calculated. We calculated the standard deviation and we found the standard deviation to be equal to 0,34664. From my calculator, I took all the numbers. And that's what we calculated. So you're going to go find the critical value. And that I'm leaving it to you to go find the critical value because then our alpha is 0,05. And our degrees of freedom is 6 minus 1, which is 5. So you go find the critical value, which is T alpha of 0,05 divided by 2. 0,05 divided by 2 and 5, which is T 0,025. Which is 0,025 and 5 degrees of freedom. Go find that critical value, and when you have that critical value, come substitute into the formula, and you only need to calculate that part because this part is done. 0,3, which is that. And you just substitute the values and calculate that part and find the correct answer. And that you have the time, and we also taking that 10 minutes break. So once you have quickly calculated it, then you can take a 5 minutes break and go make yourself tea or coffee. And let's meet again at 5 past 4. Let's make it 5 past 4. But you can continue working on this exercise. we all back? Hello? Are we all back?
I'm here.
Yeah. Were you able to calculate the margin of
Yes.
error? Okay, and which option? What was the critical value? Let's start with the critical value. What did you find as a critical value? So it means you went to the T table. Let's go there together. Go there together. So our critical value
will be 2.571.
So you went there and 5, né? Which is 2.571.
Yes.
And you went there, substituted it 2.5. And you multiplied by the standard error, which is what we calculated earlier, which is 0.33. I'm going to stop right there, divide by, but you're going to use all the values, divide by the square root of n, which our n is 6. And you get the answer. So when you say 0.335 divided by the square root of 6, multiply that with the critical value of 2.571, and your answer will be, I hope you all got it right. So the answer will be 0.3 plus or minus 0.35, and I think they leave it at 3 decimals, so we can also leave it at 3 decimals. So 5.2.
5.2, yeah, 5.2.
Otherwise, at 4 decimal, 512. It's 3.5126. Whatever the number is. So, which makes it option number 1.
Yeah.
Should have been 1.3 actually, not 5.2, because the answer it's got 6.5. So they round off somewhere quickly, and that's why it happens. Yes. So which makes it option number 1, and that's how you answer the confidence interval question. And you have lots of other exercises because all this comes from your past exam papers. So you can go and do this one as well. And that concluded our other one. So, any other question? The other thing I need to mention as well, if you are using any other calculator except the one that I used, which is the sharp calculator, whether the scientific one or the financial one. If you are using a Casio, let me know. I don't have a Casio, but I can take you through the steps. So we can discuss that outside of this on how you can use your calculator to calculate this, the mean and the standard deviation quicker and faster without you having to do it using the formula. Because in the exam, you don't have the luxury. Time is very short. So we need to find all other useful ways of doing of achieving the same answer without spending more time. And then time can be spent in validating our answers and making sure that we have the correct answers in front of us. Okay, let's continue with the session. Do you have any other question? If none, then we can look at inferences about the difference between two population proportions. We're also going to start by first looking at how we do the hypothesis testing for the proportions. And like with any other, when we work with proportions, sometimes they might give you your sample proportion, sometimes they might give you your observation that satisfies the sample proportion. So we need to make sure that some assumptions are made. And with the proportion as well. So it means your population proportion, and I must state right here because then your population proportion in your module, I think they use capital letter P. So for example, that will be P1 minus P2. And it means we need to say our sample size n minus our P2, P1, sample size 1 multiplied by the population proportion for 1 should be greater than 5, and the same should be for 2. The mean should always be greater than 5 for the assumptions to be met and for you to be able to do the hypothesis testing for the proportion. And our point estimate, which are our sample estimate, and in your module, you're going to use PGAPI, and we're going to continue using those as our sample proportions. Okay, like with the difference, with this one, we need to calculate the pooled proportion because then we are using two proportions, and to use the two proportion, for you need to calculate the pooled variance or the pool estimate, which means our pool proportion or pool estimate for our proportions will be your observation for x1 plus your observations for x2 divided by your sample size 1 plus your sample size 2, and that will give you your pooled estimate. And we will use this when we calculate the test statistic, because then we will use this to calculate, we will use the pool estimate when we calculate the standard error as well. And this is the test statistic which you will use to make conclusion based on the critical value that you will get, and the test statistic you will use that to find or to make your decision. And that test statistic, which is the Z test statistic, is equals to your sample proportion for 1 minus your sample proportion for 2. And remember, for you, we use the P guppies. So where you see the small p's, it means we're talking about the sample proportions in this constant. And minus our population proportion difference, which we always know that it's always going to be equals to 0, divide by the standard error. And when we divide by the standard error, remember that pooled estimate multiply by 1 minus the pooled estimate times 1 over n1 plus 1 over n2. And remember, your pool estimate is x1 plus x2 divided by n1 plus n2. And in those cases where they didn't give you the sample proportion estimate, we're going to calculate them by using the observations, which are your x, divided by your sample size, which is your n. And if they gave us the proportion, and how will I know that these are the proportion? It will either be in a decimal, so it will say 0.9, or it will be in a percentage, they might say 60%. And those are your proportions, and you just use them. But if they say 8 out of 10, therefore it means they gave you the events, which are your x. So let's look at an example. But before we do that, remember the 6 steps of hypothesis, they also still apply. State the null hypothesis and then alternative. State what you are given. And it will also be helpful to know that you are doing a Z test. Therefore, it means you need to know which table you are going to be using to go get the critical value. And in order for you to be able to do the to take or make a decision. And then you need to go find the critical value. And because we're doing for a proportion, every time you do any calculation for the proportion, your critical value, you're going to find it on your Z table, because we're going to find the Z test statistics. Therefore, it means we need the Z critical value as well. And the critical value will define your margin of rejection or your rejection areas. And then we can calculate the test statistic. And for this, we will use the proportion test statistic. And then we make the decision. So let's look at the example. But before that, these are how you state your hypothesis. So remember, these are our capital letter P's, P1, this is P2. Those are the capital letter P's in terms of your module, how you define them. But you're also going to check your rejection area, because in this instance, your null hypothesis says is greater than or equals to. And remember what I said, it doesn't really matter whether we have greater than or equals to there. We can always put it as an equal sign, because what matters is what the researcher wants to prove, and it goes into your alternative in order for us to define what the sign will be or where your region of rejection will be. So when it is less than or equal or greater than or equal, then the alternative will state the otherwise. So in this instance, our null hypothesis is greater than 0. So it means our alternative is less than 0. And therefore, it means we have only one rejection area, and we can reject the null hypothesis if our Z state is more than or is less than our critical value. And we do the same when it's less than. The alternative will say it's greater than, and our rejection area will be on the right. And this is a one-tailed test as well. And for a two-tailed test, we have two rejection areas. And for this purpose, then we are able to reject if it falls within any of those two rejection areas. Okay, so let's look at an example. Is there a significant difference between the proportion of men and the proportion of women who will vote yes on the proportion of proposition A? So let's say people are voting. Do we know if there are any difference in the way people vote on this proposition? And we know that the sample was selected from a random sample of 36 out of 72 men. So there already we are given our X observation, and we are also given our sample size. So we can define them. This is X1 because it comes from the sample N1. And we do the same. 31 of the women out of 50 indicated yes. So we can also define this as our X2, and this is our N2. If we need to test this at a 5% level of significance, now we need to test it at the 5% level of significance. What I need to also say is when we do the critical value, we're going to be using the Z critical table, which is the cumulative standardized normal distribution table. But we will get to it right now, just now. So let's do the hypothesis testing. We know that the first step of doing the hypothesis testing is to state your null hypothesis and your alternative. Our null hypothesis states that the population mean 1 is equal to the population of mean 2. And why? The population of mean 1 is not equal to the population of mean 2. There is a difference. Step number 2, state what you are given. And we know that we are given all those other things, and we can calculate also what we are missing. We are missing the sample proportion, which is 36 divided by 72, which gives us 0.50. And for the proportion 2 for women is 31 divided by 50, which is equal to 0.62. We can also calculate our pooled estimate, because then our pooled estimate is our X1. Remember, we define our X1 as 36, so it will be 36 plus 31 divided by 72 plus 50. And that gives us 0.54. and that is our pooled estimate, because we will need to use this when we calculate the Z state or the test statistic. Okay. Calculate the test statistic. We know that we use the sample proportion 1 minus sample proportion 2 minus, we know that our population proportion difference will be equals to 0, divided by the standard error, which is the pooled estimate times 1 minus the pooled estimate multiplied by 1 over N1 plus 1 over N2. And we substitute the values. It was 0.50 minus 0.62 divided by the pooled mean, or the pooled estimate was 0.549 times 1 minus 0.549 times 1 over 72 plus 1 over 50. And we calculate that and we find that it is minus 1.31. Our critical value, now we use the critical value for Z, which I think I omitted to mention that we're going to use Z, which is alpha divided by 2 for the question, because it said the mean difference and it was not equal. So it means there are 2 critical values that we're going to be finding. And therefore it means this will be Z. Our alpha is 0.05. So it's 0.05 divided by 2. I cannot write it there. Let me divide by 2 there. And that will give us Z 0.025. Now, on the Z critical value, when we find that, we go to the Z table, which should be the first table on here. And I need to mention the following. So the Z table has 2 sides, has the positive side and the negative side. How you find the critical value? Because we know that our critical value is Z 0.0250. As you can see, on the positive side of the Z table, the values are very big. They are huge. So it means we cannot find it on the positive side. We're always going to find them, the critical values, on the negative side of the table. So we go to the negative side of the table. I'll go right to the top. And we look for 0.0250. We don't look at the top because our critical value for Z table, our critical value is our Z values. So we look inside the table. We come inside the table, we look for 0.250. And that is that number there. That is 0.250. And once we have that, we go outside the table and we read that value, which is, ignore the negative side or the negative sign.
Sorry, ma'am.
Yes.
Can you share the table, please? We don't see the table here.
Let me share the screen because I think I didn't share the screen. Okay. Are you able to see the screen now? Okay. Yes, you are able to see the screen. So I said you're going to look for 0.250 on the Z table, and it is the first table, and it looks like this. So inside the table, you go find 0.250, which is the value there. You go out, and you can ignore the negative. You take the 2 values, which is 1.9, and then you go up, and you can see that the last digit there is 6. So the last digit on this number will be 6. And that is our critical value. Our critical value is 1.96. As you can see, it's different to how we found the critical value on the T table. On the Z table, we use the alpha divided by 2 to go find that critical value. On the table, we go outside, go find the values of Z. And that is our critical value. And once we have the critical value, once we have our critical value, which is 1,96, we can call it a plus or minus because it comes from both sides of the, it's going to be on both sides because we're doing a two-tail, and we can just do our rejection areas. We can define where our rejection area and go see where our test statistic falls in. And when we are able to identify where our test statistic is, and we can make that decision. And the decision will be, we are not going to reject the null hypothesis because the test statistics falls within the do not reject area. Therefore, in conclusion, we can say there is not sufficient evidence that there is a difference in proportion of who will vote yes on that proposition for men or women. So there are no differences. They will vote the same way. And that's what the hypothesis testing for the proportion looks like. And with that, we can look at an example of how the question in the exam looks like. In the exam, like we did with the first one where we looked at the matched sample, with the proportion as well, they give you the statement. And for example, on this one, they say your null hypothesis is equals to P2, given the information below. But they also want you to be able to know what the alternative is, because then the null hypothesis makes no difference. The difference, what you need to know, it will be asked in the question or in the statement. It will be placed in a statement. For example, here they give you your X values. So it means you should be able to calculate your P1, which is your X1 divided by N1. And you should also be able to calculate your P2 or your sample proportion 2, which is your X2 divided by N2. And then they also give you what your sample size is, and they say the sample sizes comes from an independent random sample which has N1 and N2, which we can use to calculate also the proportions. And we're going to use those values to calculate them. And then they also tell you that using the data from above to decide whether the percentage of the proportion is of the population proportion 1 is less than the percentage of the proportion population 2. Remember now, the key word here is less than. So therefore, it means you need to know what your alternative hypothesis will be. So your alternative says it's less than, and when it's less than, we know that this, and it means we are going to be doing a one-tailed test. And what I didn't mention is, with a one-tailed test, when we do the hypothesis testing, and we go find the critical value, remember for a two-tailed test, for example, with this one, with the previous one, our critical value, we went and we found it using a alpha divided by 2. That is only when you're doing a two-tailed test. This is for a two-tailed test. For a one-tailed test, your critical value, you're going to find it using the value of Z alpha. You only use that as your critical value. But let's look at what the question is asking you. The first option, you need to find the incorrect answer. The first option is asking, what is the alternative hypothesis? Based on the information you just read and based on what I just highlighted, because I gave you the answer right now, you need to say whether that statement is incorrect or is correct. So the less than it's a giveaway to show you that your sample proportion should say it's less than P1 minus, or it's less than P2, your population proportions. And option number 2 is say, what is your sample proportion? And I've already highlighted that when I did the number of successes at the top, when I say, you can calculate your P1 copy, which is your sample proportion. So it means you can calculate that and come here and say, what is that? Is that correct? So for this one, there is your answer. For that one, that's how you're going to answer that one. And step number 3, it's asking you, Since we are doing two proportions for the proportion, it's the Z test the correct one. So always remember, for the proportion, we always use the Z test. For the others, we use the T test, but always remember, for proportion, you are always going to use the Z test. And that question was asking you, is Z test an appropriate one? Is that incorrect or correct? That's what you need to make sure that you understand that. And number 4 is asking, the pooled estimate for the population proportion is that. Remember the pooled estimate, which is the P dash at the top, which is your X1 plus your X2 divided by N1 plus N2. You need to calculate that in order for you to say that is incorrect or that is correct. And that's how you answer that question. And then the last part, which asks you to calculate or to find if the standard error is incorrect. In the exam, you're not going to get all the formulas. I need to also bring to your attention the following. In the exam, you're not going to get all the formulas. So the formulas are at the back of your past exam paper. You can go and familiarize yourself with those formulas so that you are aware of which formulas you get in the exam and which ones you do not get in the exam. I need to make it a little bit, it goes over 2 pages. So this is the first page and the second page, and the first page is this one. If you look here, I'm not going to show you all of them. I'm not interested in all of them. The second one and the third one, we used it last week. Oh, not actually, not really. We used the third one and the fourth one. We used it on Monday, and the fifth one. So today, if we look at what we did today, you can see that the formulas that you get in the exam are only those formulas. That one we used for this first session, and also that one. And now we are using the Z, and you can see that they are not giving you all their formulas, but they do give you the formula to calculate the pooled mean. If you don't remember how it's calculated, then you can come and calculate it here. They don't give you the formula to calculate the mean. They do give you the formula to calculate the standard deviations and all that, but not for the mean. So you need to know all those other formulas by heart. So the pooled estimate, they do give it to you. So you calculate the pooled estimate there and you go find that. The other thing that I need to mention is the standard error. If, for example, like that question, they're asking you, what is the standard error? And we know that we're working in the population proportion. You must know that the standard error is just that part. So this calculates the standard error. The standard error is just the part below in the square root. The square root of the point is the pooled estimate times 1 minus the pooled estimate times 1 plus 1 over n plus 1 over n. And that is your standard error. And you take that formula, you use it to answer that question. And that's how you answer the questions or do your hypothesis testing in the exam with those kind of questions. Lucky enough, on this one, they're not asking you to make any decision. So if they ask you to make the decision, you go find the critical value on the Z table. And because you will be using one tail table, and you go find that value. Okay, any question? If there are no questions, then we can look at the confidence interval. Do you have any question? Is there a light at the end of the tunnel? Or there's still a long way to go? Okay, absence of questions. You have more other exercises. I took them from your past exam paper, then you can go look at how I think this is repeating. So lucky enough, this question had came up in 2 exam papers. As you can see that some of them, they come back from multiple exam papers. And if I look at both of them, they are almost similar, but they are different. There's only one thing that is different from there, but you can see that it comes from 2 multiple exam papers. So it means you need to go practice and practice and practice and practice. So also they might ask you to calculate the test statistic, and the test statistic is that Z statistic that you need to calculate, and then find the answer for it. So you just need to calculate the Z test on this question. So you can go and do this exercise on your own time. Confidence intervals for population proportion. The formula we use, the point estimate, plus or minus the critical value times the standard error. Remember, this is your sample proportion, and I'm just going to do that.
It seems like the screen is not showing the information.
Your screen is not showing?
Yeah, it's not.
Okay. Let me reshare again. I'm going to stop and share again and make sure that everybody can see. Can you see it now? Okay.
Yes.
All right. Cool. So I was saying this is to calculate the confidence interval for the proportion, and we need to find that if the mean difference of the mean proportion of the difference proportion of the population 1 and population 2 are included in this confidence interval. And like I said, these are your sample proportions, so you can put the gappies there for your sample proportion. So we use the sample proportions for this. And in this slide, I'm using the P1, P2, and these are not capital letters because they are small letters. That's why I define them, because my population proportion is in a pie format. But in your module, there are P gappies. So let's construct a confidence interval for the population proportion that lies between the proportion of men and the proportion of women that have voted for proposition A. We have the information, we know what the information, the information is. So we need to go and test this statistic. So to do that, we know the formula. Our formula is P copy 1 minus P copy 2 plus or minus our critical value of Z alpha divided by 2 times the standard error, which is our P copy 1 times 1 minus P copy 1 divided by N1 plus P copy 2 times 1 minus P copy 2, which is the sample proportion for 2 divided by N2. Now, we know that our sample proportion for P1 was 36 divided by 72, which is 0.50 minus the proportion for sample 2 for women was 31 divided by 50, which was 0.62. 0.62 plus or minus. If we go to the critical value, we've done this. I don't have to go and show you again how to find that critical value. We remember that our critical value for 0.05 divided by 2 was 0.62. 250, and we went to the Z table, and we found that the critical value was 1.96. Remember that. And we can just come here and substitute 1.96, and then we're going to multiply that with this whole thing, which is 0.50, 0.50 times 1 minus 0.50 divide by our n for 1 is 72, divide by 72 plus 0.62, 0.62 times 1 minus 0.62 divide by our n of 50, and we need to take the square root of all this. And to solve this problem, I'm going to change my pen to black, or let's make it blue, so we can see where I'm writing. I ran out of space, so I'm just going to write the answers of the square root after that, multiply by 1.96. So the first one, I will start with 0.50. So it's 0.50 times into bracket 1 minus 0.50 close bracket equals divide by 72 equals 0, I'm writing them somewhere on the piece of paper. I'm not going to write them on the board. 0.003472. And I must do the same with the other side. 0.2.62 times into bracket 1 minus 0.62 close bracket equals divide by 50 equals plus 0.004712. Now I need to add both of them together, plus 0.003472, which I got from the first one, equal, and the answer for that was 0.08184. And I take the square root, second function 3, which is my square root function, equals, and the answer I get is 0.90465. And I'm going to multiply that with 1.96. Multiply that with 1.96, and I get, I'm going to write only the final answer that I have, which is plus or minus, because I'm running out of space, 0.177312, and this side I have 0.5 minus 0.62 equals minus 0.12. And that gives me minus 0.12, and I can go and do, I'm going to write it here, right here at the top, so that I have enough space, and I can split it, minus 0.12 minus, because I must do the lower boundary first, minus 0.177312, and I must do my upper boundary, which is minus 0.12 plus 0.177321 close bracket. And then I solve that. Minus 0.12 minus 0.177312 equals, and I get 0.2. I'm going to leave it at 2 decimal. Let's leave it at 3 decimal because I've already wrote 2. 0.297. I'm going to leave it at 3 decimals for now. Remember, you will look at the option you get in the exam to see how many decimals you're leaving it at. And then the other side, which is the upper boundary, I get minus 0.12 plus 0.177312. 3, 2, 1 equals 0, 0.0573 0.057 close bracket. And that's how you do confidence intervals for the proportion. And since this does not require you to do a whole lot of other things, I'm going to ask you to do the exercise. And there is your exercise. And to make things easier for you, Z alpha over 2, because this is the confidence interval, we're always going to find Z alpha divided by 2. Because it's at 95%, it's 1.96. And then the rest, you just need to do it yourself. So this is P1 copy plus, not plus, minus. So the formula is plus or minus Z alpha divided by 2 1 minus the sample proportion for 1 divided by N1 plus the sample proportion for 2 divided by N2. Remember that P1, it's X1 divided by N1, and P2, that is what you need to always remember, it's X2 divided by N2. And that is your exercise. Okay, so let's see if we can answer this before the session ends in 6 minutes. What is the value you find for P1?
For P1 is equal to 0.5.
And for P2?
0.6.
And then we substitute into the formula. So that
Yes.
will be 0.5 minus 0.6 plus or minus the critical value that I gave you, which we know that it will be 1.96 because we've been using it, times the square root of everything in there. So I'm just going to write the formula and then you will give me the values because I didn't calculate.
So it's 0.5, 1 minus 0.5 over 20. Zero comma 6 bracket 1 minus 0.6 over 30.
Okay.
Okay. So after it will be inside the square root, it will be 0.25 over 20 plus 0.24 over 30.
I'm going to run off space if I write everything out. Yes, continue.
So basically, the answer, the result will be 0.28063.
Okay. So that will be plus or minus. Is it after the square root or before the square root?
After everything. And 1.96, we have multiplied 1.96, it will be 0.2.
Okay, you also multiply the 1.96. So the answer you get is
0.28063.
And then on the other side?
Minus 0.1.
Okay. Minus 0.1 minus 0.2860. And on the other side, minus 0.1 plus 0.8603. And your confidence intervals are?
So the lower is minus 0.3806. Three, yeah, and then the upper is 0.1806 2. 0.1806
Okay. When you do the calculations, please bear in mind your rounding off quickly. So you must make sure that you leave all the decimal places so that then your answer, you are able to find it on the question itself as well. Because when you cut off the answers while you're still busy calculating, you might have problems with the answer that you get. Okay, so and then the answer is option number 3.
Option number 3.
Okay, and that concludes today's session. You also have more other exercises that you can follow and do at the later stage. Otherwise, then everything we can discuss on the WhatsApp group if you have any questions or you still need more clarity on what we have done so far. Any question? If there are no questions, then we can recap and close off the session. So far, we've learned how to do hypothesis testing and confidence interval for the paired samples when we have two populations. And then we also looked at how do we do a hypothesis testing and the confidence interval for the proportions. And that concludes today's session. Thank you for participating and thank you for coming through. I will see you next week, Monday again. Otherwise, we can continue chatting on the WhatsApp group. Thank you, guys. Bye.
Thank you. Thank you.
Remember, if you also are struggling to do those calculations on your calculator and you want me to show you the shortcut, let me know, and also let me know what kind of a calculator you are using so that then it makes it easier for me. And then we can take on those conversations on the WhatsApp group as well. Thank you, guys. We got one hour, Parecia.